Hello friends, welcome back to another session on operating systems. So we are looking into the various types of system calls. In the last session we have seen about the process control system calls. Now we look at other system calls. So let's begin with the file management system calls. For managing the files, the system calls like creating a file, opening a file, reading a file, writing a file, closing a file are the various system calls which we require whenever a user wants to create a file, has to use a system call because the user is working in the user mode and any file operations will be done in the kernel mode, so the switch of the mode has to take place from the user mode to kernel mode, and that is possible only through the system calls. So whenever any file operations are to be performed, so we do have system calls. A system call is there to create a file. So in the agenda figure you can see that we are creating a file. We can open a file, so we are saying fopen and we are giving the name of the file, and then we are saying what way we need to open it. We want to just read it or write it or even execute it and all that. So in this case demo.txt is the file name and we are opting for writing. And if the demo.txt exists in the directory where we are working in, and then if the user has authority to write on the file, only then the file will be open. And when the file is open, some more than 0 value is returned, and that is stored as a FP. If the file does not exist, or if the file is not available in the directory, or if the write privilege is not for the user, then the file will not be opened and you get a -1. So we need to verify whether it is -1 or not, and then continue working. If we get a -1, that means the file is not open. Want to read the file, so we can have read, write, and finally we need to close it. So here we are using getC, putC are the two functions. So putC, it takes from the character, puts it on the file, so this is for writing, and getC is gets from the file and prints it. So the getC is a system call that gets the one byte or one data at a time, and that is put in the loop till we reach end of the file. Same thing happens here also. So these are the various system calls we have for operating the files. Then these files do require access control, and these access control are in three types of access control we can provide. We can provide a user only read access or write access or execute access. So we can allow some user to read a file, or we can allow someone to write onto the file or modify the file, or even can allow someone to execute the file and all that. So in that we have R means having a authority to read, W means having authority to write, RW means read, write, both can be done. So in here we are shown with three positions, and we have three users here. So the first position, so these three things are talking about the three files. So this says we have a file 1 and has got two connections. That means the user 1 and user 3 has access to file 1 and both of them have read access only, and user 2 Bob does not have access to file 1. Same way file 2 Alice will have a write authority. Bob can only read but Fred cannot read or write or anything. Same way file 3 Alice can read, write, Bob can only read, Fred can only read, and all that. So these are the what we call the file metadata. So the information about the file, about regarding who can access the files and all that. So these details are stored in the metadata, and whenever a user tries to open a work with a file, then this system calls will first verify the access control metadata and then make sure that whatever operation the user is trying to perform is a valid one, is allowed one, and the user is privileged to work with the file the way it is expected, and if it is so, then it will be allowed, otherwise error is raised. So that's about file management, and then we'll get into device management. The devices, as we have discussed earlier, that anytime only one of the device can be used because there is a single processor. So when we have such a thing, then it is better to work in the form of a bus. All the devices can be connected to the bus, and through the bus all the operations can be performed. So if we want to interact with any device, then first thing is we just request that we want to use the device, and if the device is ready, it will be available, and once the work is done, we release the device. And then we were trying to read or write from the devices. So if we are looking for the reading, then from the input device it gets to input controller, then we have input device driver, so that it talks about the protocol in which the input device is working and all that, and then it gets into the ready queue, and the data whatever is read is put on the ready queue, and whenever CPU is free to read the data, it can read. The only reason why we have queue here is the CPU's working speed and the IO device working speeds do not match. Therefore, in order to optimize the CPU's working, we just make the IO operations in the background, and once if we want to read something, then the CPU will inform the input device to read something, and then it just continues doing its own work. And when the input device reads the data, then puts onto the queue and informs the CPU that the data you have requested is ready on the queue. Whenever you are free, just go through it. Same thing happens whenever CPU wants to write onto the device, then it just dumps it on the output device queue, and then this data goes to the output device driver, and then it verifies the protocol in the way it is to be written and all that, and then output controller, and finally goes to the output device. So these read-write activities we need to look in detail in the future sessions. So that's what happens with device management. Then we have some system calls that is meant for information maintenance and communication. Like we do use timers, and for timers we just set the timer, we get the how much time has elapsed and all that. So in case of scheduling and all that, as we discussed in the earlier session, process control session, the scheduling, each process is given some slot, and to make sure that after the slot is over, the process has to stop, and the control has to go to some other process and all that. So all these activities are taken care by the timer and set timer, get timer, and all that are the functionalities provided by the information maintenance and communication component. And one of the important activities taken care by the system calls is inter-process communication. So there are multiple processes working in that, and if we want to communicate between the two processes, then again each process is working in a user mode, and to ensure that inter-process communication takes place, one option is have a shared memory, so that both the process A and B have authority to seep into and peek into this memory and read and write into this memory. And if process A wants to share data with process B, then process A will write onto the shared memory and process B will read from the shared memory. So this way the message is being passed from A to B via shared memory, or otherwise the message can be passed from process directly to the kernel and from kernel back to the other process. So different kinds of process controls, inter-process communications are possible. So that's about system calls, various types of system calls we have seen, and more details in the coming sessions. In the future modules we are going to see all these in more detail at the implementation level. So till then, keep watching. Thank you.